Okay, if you need a few examples on how you do calculations involving prisms, I'm going to give you a couple examples right now, okay? So first thing that we need to recognize when we have a prism is that we have two congruent polygonal bases. So in this crazy guy, we call this a trapezoidal prism. That's our one base. We name them by the base, and that's the other base. Now, if you can identify the bases, and over here, of course, we have the hexagon bases. If you can identify the bases, the height is always the distance between the two bases. So for our hexagonal prism, the height is definitely what you would call the height on the side there, going between from top to bottom. However, the trapezoidal prism is basically sitting on one of its lateral faces. Therefore, the height is going to be this length, or you could pick any one of these. And it's not what you would picture to be the height, because it's not sitting on one of its bases. Okay, that's going to come into play when we actually do our calculation. So I wanted to clarify that to start. Let's go ahead and look at an example. We'll start with a triangular prism down here. I think the rectangular prisms are the easiest, so we're going to skip that for right now. Find the lateral area and surface area of this triangular prism. So we do have some formulas for this. Let's go ahead and write out our formula. Lateral area equals P times H. P stands for the perimeter. I'm talking about perimeter of the base. So I'm taking my base, which is right here. And we're going to take the perimeter of that, which is 8 plus 6 plus... Okay, at this point I get stuck because I don't know what this other length is. So how are we going to find that other length? If you're seeing a right triangle, and if you're thinking Pythagorean Theorem, you're exactly on track. I'm not going to do the Pythagorean Theorem right here. I'm going to let you do that. I'm going to set it up for you. 6 squared plus 8 squared equals c squared. C comes out to be 10 in this case. Plug that in, times the height, which I pointed out to you, distance between the two bases, is 12. So that gives me altogether 8 plus 6 plus 10 is 24 times 12, and that's giving me a final answer of 288. We're going to use square feet. We're not doing volume yet, so square units, just like if you're doing area of a two-dimensional figure. We're doing the area of all the two-dimensional surfaces. We're just adding them together. Okay. Part 2. So other formula, we've got total surface area is the lateral area plus, I'm going to switch that around just so it follows the formula that's on your page. I'm going to say it's 2 times the base area plus the lateral area. Lateral area refers to the area of all the rectangular sides, everything except the bases. So now we're adding 2 times the base area since we know we have 2 congruent bases. So, good news is, hey, I already have this answer right here. The lateral area is 288. So I'm going to be adding 288 to twice my base area. When you get to the base area part, you're going to have to insert a formula here. And in this case, the formula is going to be the area of a triangle because my base is this lovely right triangle. So I'm thinking 1/2 times base times height for my area of my triangle. Putting some numbers in, 1/2 times, since it's a right triangle, we can call the 6 the base and the 8 the height. 1/2 times 6 times 8, and then I'm going to have to add the 288 at the end. I do like to go ahead and calculate the area of the triangle and then multiply by 2, and that's because when we get to volume, it's going to be helpful for us to have that area measurement. I'll show you in a second. So I'm going to go ahead and say that's 24, multiplying that times 2, plus 288 altogether. 2 times 24 is 48, plus 288. That's how I'm getting my answer of 336 square feet for the total surface area. Okay, I said that that base area was going to help you. So let's go ahead and finish our triangular prism. And let's go ahead and do the volume. Remember, the base area that we got was 24, because I'm going to use that in just a second. Okay, I need a little bit more room. So I'm going to go to the back side. Join me on the back side and find that same figure on your paper on the back side. Whoops. There we go. Okay, so there I am on number 4. And I want to find the volume, and yes, you should be noticing that this guy is exactly the same picture that we were just looking at. New formula. Volume is base area times height. That big B stands for base area. Some people actually like to write BA, because that's what I just called it a second ago. So you can put BA, or you can just put capital B. Don't use a lowercase b, then we're going to think it's a unit measurement. And then that height, we talked about that height distance between the two bases. So I do know that the height's going to be 12. And for the base area, I would be plugging in my area formula for a triangle, which is 1/2 base times height, 1/2 6 times 8, which we just did. And hopefully you remember, or flip back to the front side. That was, whoops, I'm sorry. Apparently I don't remember. That was 24. So at this point, if you've already done the area of the base, if I hadn't done it, I would have to redo that. If you've already done it, you're down to 24 times 12, and that gives you 288. Coincidence that this is the same measurement as the lateral area measurement. Okay, sometimes that happens, but that's not going to happen all the time. Volume, 288 cubic feet this time, since we're talking volume. Okay? Okay, let's go back.